Okay, welcome everybody to this week's workshop, and our topic will be an overview over the different backends of OpenQA, or rather OS AutoInst. I will give a short overview where you can find the documentation and so on, and then we will dive into the general hardware backend. The idea is to make more of such workshops to also cover other backends. So if you are interested more in a different backend, we will likely at some other workshop get into it. But yeah, for now I start with the general hardware backend. And yeah, that's the most important documentation about it, what you can see on my shared screen. So that documentation is actually a markdown document which lives under the OS AutoInst repository. That's because it's of course specific to OS AutoInst, and it's not included in this large document from OpenQA itself. And it goes into different backends, many of those which we will not talk about today, so I also won't cover it now. We will talk about the general hardware backend, which is only mentioned here in the end. It can be used to test on real hardware as stated here. We will go into a more concrete example, which is also linked here in maybe a minute or two. But first, some general recommendations. You can find all variables that are specific to certain backends in another document. For instance, for the general hardware backend, we would have many variables which are also usually prefixed. And maybe we will go into the meaning of these later. But we have explanations for many of these things. If you are wondering how to actually run a test using an exotic backend, let's say you find a test on OpenQA, our public instance, or maybe our internal instance, and want to run it locally because you want to develop the backend specific code, then of course the problem arises how to run that. And one approach would be to take out a worker from production, and we also have these steps covered here. Of course you should in the end bring it back when you're done, but that's the simplest approach. I often use it to test backend specific code. You can of course also try to replicate the setup, but that's often more involved and also not always possible, especially when it comes to the general hardware backend, because you maybe simply not have that hardware. I was mentioning that I will go into a specific setup for the general hardware backend, and that's testing on Raspberry Pis. Currently it looks almost like this picture. We had to move stuff around, and the Raspberry Pis were no exception to this, so it looks a bit messy. And we will go into this a little bit Yeah, actually, right now we have Dominic here in the talk who can give us a bit more insights about it because he's currently maintaining those tests. So you can say hello, Dominic, if you like.
Hi.
Um, yeah, so he actually also wrote a lot of documentation when he developed this, so you can actually find it and read all the details yourself. Um, that's not on this page because it's also, of course, specific to the tests themselves. So it's in OS Auto Distri Open SUSE. Yeah, before we go into this, I will shortly say that this is not the only setup. For instance, on O3, you can find these workers if you just search for Pi. You can actually do the same for our internal instance. I don't share anything special here. This just, I mean, the three, not Grenache, the three here are just the workers you've seen on the picture before. Um, yeah, and then you can find from there tests like here on the open instance again. And this setup is actually done not by Dominic, but by an external contributor who works for the company ARM. So you can do things like that as an external contributor on our public instance. Yeah, so the tests look more or less normal, except that, of course, the backend is set to general hardware and there are some specific variables, um, as you saw before in the documentation. Yeah, but I think we will go into that right now and I will ask Dominic a few questions, how he established that setup, and I think the most interesting setup is how is the screen handled? How do you get the graphical output from the system? Yeah.
Yeah, when you could you open that documentation page again? You know, the one that is not in the auto inst repo.
Ah, you mean that one?
Yeah, and scroll a bit for the overview, then it's easier to understand.
Yes.
So here, essentially, you can see the whole setup. And in the case of the Raspberry Pi 4, not the other ones, it's planned. I just ordered the hardware, but it's not yet built in. It has an HDMI grabber. This is a very new way, and we only do a limited set of testing if HDMI works. Um, actually, yeah, I think we will cover the HDMI and also the keyboard emulation topic a bit later because it's not the main way we are using we are getting the screen output. So what we are essentially doing is we boot the system on the system under test on the real hardware, and then we SSH to that system. Um, and the SSH connection is done on a virtual X server that is yeah, running an Xterm that is configured to look like a raw Linux console. And this allows us to reuse all of the needles so that yeah, essentially for the user, it looks like if it was a raw Linux console, but actually it's an SSH connection to the system that yeah, virtual X server runs on the normal worker host.
Okay.
Yeah.
Um, do we see any of this setup work here in this job, or is it already a
Um,
HDMI job?
that one, let's say, no, this is the, let's see, yeah, this is here, for example, if you open one of the first run of the blue boxes, especially, let's see, every result but this one. This one is actually HDMI output.
Okay.
Uh, yeah, so this is just to see if the console is there, and then it is also, if you, yeah, we can also cover this now. If you go one image to the right, then you can see here it was successfully able to log in.
Mm-hmm.
But if you then open um, the next image, then you can see here the SSH connection to the system under test is established. And
And
yeah,
this console
you,
now more is not on the real hardware but on some intermediate
yes,
system and
yes. At
okay.
this step, it switched. And you can also see that the text is a bit more readable because in the other console, yeah, I'm using a cheap HDMI grabbing device. Actually, the setup on the public instance, I'm not sure if it supports it. I think Guillaume had some tests with some special device, but I'm not sure if it was him or someone else who actually developed the HDMI part, because yeah, the initial idea I think was to use some multicast streaming device that is meant for network, for HDMI over Ethernet or something. And yeah, I'm just using cheap €5 HDMI USB grabbers.
Yes, it seems the disadvantage is that you couldn't set the resolution correctly because yeah, it's not the right one.
Yes, and so I just created a needle that has the text a bit, yeah, that's not correctly, yeah.
Yeah, you made the needle so it's still accepted.
But
Yeah.
you can still read it, and it is enough for this testing purpose. Marius, do we already want to talk about how we actually generate this image here?
How we generate the image? Yes, why not? I mean,
Yeah.
we were at
Okay.
image handling.
So if you, so I'm now talking about the disk image. If you scroll a bit up and go to dependencies, um,
Ah, you mean the image on disk? Yeah, but why not? Right.
yeah, so the thing is, on the external instance, we don't need this because the OpenSUSE images by default do DHCP and have a default root password to log in. The SLI variant doesn't have this by default. By default, it runs this assistant, um, some graphical assistant that you can run via HDMI or via serial, and that will ask you, yeah, what keyboard layout do you want to have? What root password do you want to have? Do you want to connect to a Wi-Fi? And if this thing is not run through, it doesn't have. Yeah, here you can see the blue icons.
Yeah, I'm not sure. Should I show this? It's on the internal instance. I'm not clicking here.
If you're using the build number I supplied to you, it's a public beta anyway. But
Right, it's a build number you supplied to me. Okay. Yeah, then
but
I can maybe click
it's,
on
it's
it.
not it's not much. The software is open source, so and it's the same thing you can also use on Tumbleweed. Um, yeah, you can. Yeah, you can see here how the assistant is yeah, clicked through. And we're
Yeah.
using OpenQA for this because OpenQA is best with this. So we are using the raw.gzip image provided by, yeah, that's as it comes from the build servers. Um, Then here we are
That
in
you
this,
can likely see here, except that the asset has been cleaned up and only the SHA sum is remaining.
yeah, and then it will automatically be yeah, put through this assistant. Then we do some cleanup before we shut down. For example, delete the file that would make ETH0 ETH1 if the MAC address changes. And then we are yeah, saving it to a QCOW file. So in the actual test with the general hardware backend, I'm getting a QCOW file and not the raw file. And yeah, then I am flashing this QCOW file onto an SD card, essentially. Because it's a QCOW file, I first need to convert it back to a raw file. I'm actually converting it and not using QEMU network block device, mainly because I didn't know about this, but also because then I can run most of the commands as an non-privileged user. Um, the worker host is actually also a Raspberry Pi, but one with 8 gig of RAM. So I can do this in the RAM. And yeah, then I can flash it. If you, Marius, when you show the photo again
Yes.
and enlarge it a bit and go a bit to the left, you can see this special PCBs. It's a bit hard to see because the angle is not ideal, but you can see that there's some special hardware connected to the SD card slots for the left 3 Raspberries. That's some device that also Guillaume is using for the public instance setup. Essentially, it's an SD card multiplexer. It is a small PCB um, that you can yeah, put into the SD card slot, and then on this PCB there is another SD card slot where you put in the real SD card, and then you can via USB from external um, put the SD card into yeah, onto the actual worker. So you can yeah, you actually posted it. Yeah, it's this device from Linux Automation, and yeah, we can switch it over to the host. Yeah, here you can see it much better. You can
Yes.
switch over to the host and then via USB flash it like it's a normal SD card reader, because it is. And then the the chip supports yeah, switching the SD card over and just passing it through to this yeah, PCB piece emulating the shape of an SD card. And that works pretty well. If you're using Samsung SD cards, with SanDisk it didn't work, for me at least. Yeah, and this is essentially done by a script. I think if you go to the documentation where my nice ASCII thing is,
Yes.
uh, it should mention the name of the script. I think it's flashsd.sh, and I'm using actually flashsd rootless.
Ah, yeah, here it's mentioned.
Yeah, which is a stripped down version that does what we need for the internal instance, because the normal flashsd was a bit yeah, was a bit much code that I didn't need. So yeah, I created the second script. This script is mentioned in the worker.ini file um, on the worker host. And essentially it gets, yeah, the SD card, the image to be flashed, and then the serial number of the USB SD card multiplexer. And then it can get the right device, switch the SD card over, flash the stuff, switch the device back. Yeah, which takes some minutes, of course. Yeah, but that's okay. It's it's
Okay.
have time. And what we also see here is the Paiku keyboard
Yeah, I
emulator.
just wanted to say, I think we handled now, we covered now all about the image handling, of course, the most important parts. Right, so maybe let's continue with the input handling, which is usually the next problem you will have to solve. Right, and it's done by this RPi Pico
Keyboard
keyboard
emulator. Yeah,
box here, right?
yeah. So I think other setups. I'm not sure. There might be a setup, but I think it's not the one of Guillaume, but the one of someone who tested laptops. Um, I think that person might be using some more complicated device for input thing for yeah, sending in inputs. In the past, there was some approach with OpenQA. It's a very long time ago that we were using some device called KVM to USB, which needed some special driver that the vendor created for OpenSUSE. We had to ask them to compile it for the new kernel version because it was closed source. It was very annoying. Um, Also, it was using VGA. Don't get me started on VGA artifacts. Anyway, that was very expensive and it was a bit complicated. What I'm using now is a Raspberry Pi Pico microcontroller. So
I
yeah,
can show you the image of one.
yeah, it's essentially like an ESP32. I'm using the Wi-Fi equipped version of the Raspberry Pi Pico. And the special thing about this microcontroller is, um, other than a ESP32, which only has a UART bridge chip, this thing does the USB on the main SoC. Yeah, you can do a USB gadget, and it's very cheap. It only costs €7. And what I do is I created some software that will, I think, Marius, you could open the documentation tab. I think I sent it to you. Um,
I think you mean that one. Ah, no,
yeah,
sorry, you mean
that
that
one
one.
is, yeah, I just opened the other one. You can see more at that one. That's the pull request where I added it. So essentially, this Raspberry Pi Pico is running a software that gives it a web UI. You can see a screenshot of the web UI here. It supplies two API routes. Um, One is the typing, and the other one is the send key. The typing is you provide a string and it types as characters. The other one is send key. You provide key combination in the same syntax that QEMO accepts, and then it will send this key. It will talk to the worker host. We remember the worker host is a Raspberry Pi 4, and it spans up a Wi-Fi network, and the Raspberry Pi Picos connect to that Wi-Fi network, get, according to their MAC address, a special, well-known IP address, and so we can send stuff to that device. That works surprisingly well, actually. Yeah, and yeah, also we reuse that Wi-Fi network for power cycling the machines via uh, Wi-Fi power plugs, and also to let the system under test the Wi-Fi connectivity. Yeah, and for this stuff here. It's a bit hidden in the OS Auto Instance OpenSUSE repo. Um, Maybe Marius, could you yeah, send the link to that documentation I showed you earlier?
Um,
Yeah, that one. Um, because yeah, here I have a manual how to flash it. Um, yeah, the Wi-Fi password is actually hard coded in the, yeah, that's yeah. That was even asked on the chat. Yes. Yeah, it's essentially not very complicated. It's just some Arduino sketch, and the keymap.h is my conversion from the QEMU keyboard send key syntax to the way that keyboard input is handled in the Arduino library. Yeah, essentially it just gets the right defines back. And here in the main file, you can send the Wi-Fi password and the SSID here in line 15. And that's essentially everything you need to. The send key presses milliseconds. It's hard coded. So usually in OpenQA, we have this type string slow or something. This thing has one fixed speed because yeah, I only needed that at that moment. So it's hard coded to something that yeah, worked fine. Um, yeah,
Yeah. Okay. Here you're generating
yeah, I'm
the
generating the web UI
web
and I have
UI.
some ring buffer for the last 10 keyboard commands just because I could. Uh,
Yeah, I think that's actually a useful feature to have.
yeah, and what I really find nice is that the hardware is so cheap that we are using for keyboard for yeah, real user interaction. So together, you are below 20 euros for the Raspberry Pi and the HDMI grabber.
Yes. Yeah, the sad thing is it works better, at least concerning keyboard inputs, than our much more expensive ARM machines we also have, where we of course run QEMU, so the emulation layer could make things worse, but yeah, still, it's quite nice to see that you can do so much on cheap hardware, especially when enterprise hardware isn't also sometimes the best. Um, okay, so let me think. Do we need to cover something else? Or maybe somebody
Maybe you
from.
could open the main hardware chart
Mhm.
again with you know,
You mean that?
yeah, yeah, this one. Um, let's see, what do we have also? The Pi worker also has a Bluetooth, discoverable Bluetooth that is always visible, which is surprisingly hard to get hammered into Linux. Um, what I essentially do is I created some custom system D unit. I think it's even described in the setup. I created some custom system D unit that runs commands for Bluetooth CTL, um, so that the system under tests can also test the Bluetooth connectivity.
Mm-hmm.
Here you can also see that the Raspberry Pi 4 has a TPM connected to the GPIO headers and some RTC. I think with the TPM we are actually using it. The RTC was cheap and so I ordered it, but I'm not sure if we are actually using it already, um, because it seems to be surprisingly hard to use it. Yeah, the Wi-Fi, the power cycling is done via cheap Wi-Fi power plugs, which is nice because you can replicate that setup at home, which is why it started in the first place with this Wi-Fi power plugs, because I created it during lockdown. And yeah, of course, in the server rack, we could have some power um, cycling professional power supply device, whatever this is called. And yeah, but at the moment, we really just have a regular power power extension thing for rack mount, which has this Wi-Fi power plugs in it. yeah, here you can see, yeah, that's the RTC module,
Yeah.
and yeah, it's just on the GPIO header next to the TPM.
Okay, maybe I could also just open this tab. Here you can see just the variables from the job we were looking at earlier. So that is apparently what you need. You
Yeah,
have a bunch of scripts, and the directory where they are stored is in one variable, and then you basically invoke these scripts for certain things, for certain
yeah,
actions, like here power on off Shelly.
yeah.
Um,
That's the power. Yeah, that's the Wi-Fi power plug. At the second line, you can see the serial number of the USB SD card emulator, and I'm telling the script to use yeah, some RAM disk to do all the operation, because otherwise the SD card of the worker would fast yeah, would quickly be dead.
yeah, that's of course the URL to the route we saw earlier here.
Yeah, and you can also see the path to the serial device. Normally, you could write TDY USB 0 or something in it, but the thing is, as far as I found out, or at least with the hardware I'm using, USB UART adapters don't seem to have a serial number or anything. So I had to take oh, and it's the same for the HDMI grabbers. So I took the work of labeling which USB cord I connect which USB hub to, and on which port on that hub I connect which UART bridge or HDMI grabber to, so that I can access the devices via the bypass. Yeah,
Okay, maybe someone from the audience can also share their setups, or at least give some general remarks, maybe what they did different, or maybe also what problems they ran into.
Hi.
Yes?
Uh, I have also a setup using general HW backend, but testing laptops, and I can also present what I did differently. But I would like to start with some questions first. Um, for video grabbing, uh, how do you deal with resolution? Because most, if not all, Open QA expect a specific resolution, 124 and 70,
yeah.
Yeah,
768.
So I had a long search for HDMI grabbers where you can set it. The only thing I really found was some thing that connects to the camera interface ribbon cable of the Raspberry Pi. There you can set the edit, but
Yes.
first I actually haven't got this camera interface running on OpenSUSE yet, and also it's only one, and I need three. So I'm using the cheap grabbers and just deal with the wrong screen resolution and created the needles for the wrong resolution. And notice if you click the button right next to candidate needles and text, the one that shows the whole screen
I
in
know.
color mode, or like this, yeah, you can see the
Oh,
text is
okay.
a bit mangled because I'm running it with, yeah, it's just scaling down or something from the higher resolution. And so I just created a needle with that, and yeah,
Yeah, Maybe I could also add OpenQA kind of supports different resolutions. I think even due to pull requests from some of you, that was at least improved. But of course, there might still be catches because we are actually not really relying on it and it isn't really well tested. However, it's a possibility, and if you don't mind fixing things here and there, then it would be possible. The reason why we actually don't really use it ourselves in the OpenSUSE tests is, of course, that we already have many existing needles that are exactly for our standard resolution, and we couldn't reuse them in a different resolution, so that wouldn't make much sense, I suppose.
Yeah, I ask. So yes, I used specifically this chip you mentioned over the ribbon cable to grab HDMI, and I can set a DID, I think it's the name, to specific resolution. But uh, this is a bit painful because I run tests on laptops, and
Mm.
what I would like to test is if everything works with native resolution,
Mm.
which yeah. So currently, I'm not testing large part of the large part of things because using smaller resolution will not get it. Um, and as for setting it under OpenSUSE, a challenge here is the driver works only with Raspberry kernel, not the vanilla kernel. It's not in upstream kernel yet. So
That's
yeah, in
okay.
theory it is. So the device is detected and pretends to be there, but the actual content is just stubs and nothing actually is handled.
That
Mm.
maybe explains why I didn't get the camera working yet.
Yeah,
Um,
that was a lot of time debugging why it didn't work, and yeah, I find that the actual function are not implemented there.
Maybe at some point later, because yeah, Maurits mentioned problems. I have one problem with the HDMI thing. It actually takes like several minutes until the video feed arrives, and I don't know why it takes so long. So
Hmm.
when I boot the system up, I can see at the UART console that the log is already there, that the system is already booted up and there's already the login prompt, but it takes a few more minutes until I get yeah, the video output of the login prompt here, or even the boot up. So essentially, I seem to have quite some delay there, and I haven't found out why.
Interesting. I haven't seen this problem. So there is some latency, like 2 or 3 seconds, and that's mostly because Raspberry is slow and the video processing is not very optimized there, at least the way I did it. Uh, but definitely not few minutes. It's like few seconds.
That's
I,
really a bit, yeah. But I mean, it's okay because I'm only using it to check if the HDMI actually works. But yeah, for more complicated stuff, it would be annoying.
Uh, I also tried for video capture network devices. Like there are some HDMI extenders that are using actual IP to transfer the data. So normally you can get two devices like a sender and receiver, but you can use just a sender and receive that using FFmpeg or VLC or whatever you like. So it's just normal video stream.
Yeah.
It also kind of worked, but it's yet another device, and yeah, it didn't scale well.
You can essentially provide anything to that backend that is accepted by FFmpeg. So yeah, I think
Yeah, exactly.
in my case it's running on the dev video device.
Yes. Okay. And I've seen some support for testing audio. Do you use any of that?
So essentially, we are testing audio in the virtual world, but I haven't tested it of on hardware yet. I mean, essentially, it shouldn't be too hard. Just adding another USB hub with some audio capture cards and connected then to the Raspberry Pi's audio outputs. I mean, the usual way we were testing audio. So at the beginning, it was we're sending DTMF tones and running a DTMF decoder on the other side. And in the meantime, we have converted it so that essentially we record the audio on the in the VM case on the VM host, and then we are converting the received audio to some to an image that's essentially an FFT function over the audio, and so we can see the frequency in one axis and the time in the other axis, and then we can see everything very nicely. We can also see what is Oberwellen in the harmonics. Um, in some cases, which sometimes breaks the test if we have too strong harmonics, which is also quite funny to have some problem from the analog world here.
I
Uh,
just wanted to show an image. Does somebody know where the Amarok test went? That is something I can remember, which shows exactly what you've just described. Ah, here it is.
yeah, you
Um,
can click the audio first. So here we have the actual recording. I'm not sure.
Likely you won't hear it.
Yeah, I hear it.
Ah,
Yeah, it's essentially all the DTMF tones. And if you open the second thing, here you can see at least some of them.
Oh, nice.
yes, and then
Okay.
we just match that image using
And,
our normal needle algorithm.
and if you open a different needle, maybe Marius, we can see one that matched not that good.
Or let's just go here.
And then can we see? No, okay, here's just the time is a bit different. But there was some time where we had the issue that we had the harmonics and here you can see the
Yeah,
harmonics. The
here it's slower apparently.
Yeah, we
Or,
also had that problem at some times that the TMF played
or
slow for some
last
strange
short.
reason. But here you can see the harmonics that yeah
Yes. Yes. Okay, that's interesting.
yeah. But
Uh,
I find the solution quite elegant to reuse the needle algorithm for GTMF tones
Yeah,
or
so
for
yeah, basically we have the mechanism there, but it's currently I think only implemented for QEMU.
Yeah, I think we don't have it in the general hardware backend, but it wouldn't be very hard. I mean, essentially, we need to implement the start audio capture and stop audio capture um, function. So this is a really nice idea. I think I
yeah.
order another
Uh,
USB hub. Um, so yeah, I mean, audio cards cost like €2. So
Yeah, I considered using simply the audio that is already in Raspberry Pi, like connect to some cable to connect to audio output from the laptop to Raspberry Pi as input. So I
and
just
can the Raspberry Pi sound card be used as an input? I didn't know that.
uh, I assumed it is. I hope I'm correct. um, because there is audio jack with quite a few pins inside. So yeah, I assume there is input there.
Hmm. Yeah, I mean, the thing is, I have three workers, so I could either mix them together, or yeah, I think that would be a good idea.
Oh, okay, I see. I have separate Raspberry Pi per laptop, mostly because I need separate Raspberry Pi for this HDMI capture thing, because I have only one camera interface on the Raspberry Pi. And
Yeah,
also CPU power on Raspberry Pi would not really allow to process multiple streams.
I'm actually still amazed that I can have three workers at the same time. The main problem was that the worker three system under test at one Raspberry Pi worker. The main problem was that the Raspberry Pi worker at the beginning had not enough RAM to hold the images of three system under tests in the RAM at the same time. Kernel same page merge didn't save me. So at the beginning, I had some crude setup with some NFS share on some other machine where it could write to. And now I got the one with 8 gig of RAM, which took some time when yeah they were at stock, and I quickly was able to get my hands on one.
Yeah, that's not easy these days.
Yeah, so
Yeah, and also for keyboard emulation, I use USB gadget, and also Raspberry Pi has only one interface. So,
mhm.
uh, do you? Oh, but for Raspberry Pi, it's only USB for keyboard, so it doesn't make any sense for different protocols. But I consider also PS2 emulation at some point in the future, but I don't have solution for that yet.
So what I heard about PS2 protocol is that it's actually quite simple, but I'm not sure if
Yes.
you have to go.
Yes, it's the protocol is very simple, and I have seen some implementations, but in practice, it's probably will be easier for me to just to implement it or modify some existing, but
Yeah, you could either do that or use a USB to PS2 adapter on the Raspberry Pi Pico.
uh, there is, yeah, that's possibility, but a tricky one, because in many cases those adapters are not actually adapters for the
Yeah, yeah,
protocols, but they only connect wires, and the keyboard detects, oh, I need to speak
I
USB
mean
over
the
this.
expensive ones.
Yeah.
I mean the expensive ones where you have a
Ah, okay.
USB, where you have two PS2 cables for keyboard and mouse and one USB or slot or something like that.
Huh. Okay. Um, yeah. All I've seen are were actually passive thing, and relied on keyboard to also speak USB, just over different cables.
If I recall correctly, just now the adapters that I'm talking about are the other way around. They connect they connect a PS2 keyboard to to a computer that only has a USB port. Yeah, that's way around.
Oh, okay.
But anyway, I guess yeah, it's just some implementation effort then, and yeah, maybe some electrical connection. Yeah.
Yeah. The protocol is very simple. So from what I've seen, yeah. Um, Okay, I've seen you mentioned also the SD card, not writing to SD card as an
On the
issue.
host system, I try everything to not write to the SD card. Yes.
Yes.
I just have a look at my at that system. If I recall correctly, yes, I have the var lib OpenQA pool directory where it saves everything. Is a temp fs actually on that system, and yeah, as you saw before, I use the shared memory. About the Samsung SD cards, they didn't die yet, which is amazing. I thought that I would have to change them earlier, but I didn't. From the SD cards that I'm using, only the Transcend ones yet died. First, we thought the Transcend was good, and now we know, yeah, for my Transcend SD cards, all of them are dead. Let's see, where did I buy them? I have to, I need to have a look. Question is where.
Yeah, I see that's really a huge topic.
Yeah,
Yeah, but
unfortunately, I don't have enough memory to hold everything in RAM because I have the installation image for cubes is over 5 gigabytes, and most Raspberry Pis I can get are not 8 gigabytes models. Some are just 2 gigabytes. So
Yes. So
that's
for that,
painful.
to work around that, I was using an NFS share on another computer that was by chance in the same lab. But yeah, that computer had an HDD. Of course, this was making everything completely slow because the Raspberry Pi is also, so for OpenQA, we usually are using this caching daemon that Marius knows much more about than I do. And
Yeah, I use that too. Yes.
on this system, we don't. On this system, we use the old-fashioned NFS share with all the files on it. Just because then we have it in the file system, we don't have to copy it to the RAM or to the SD card and break things. Yeah, here, I think that's the name of the SD card. I just ordered it on Amazon, and yeah,
Okay.
seems that yeah, maybe Guillaume has also some knowledge on which SD cards work best. I just found out that my SanDisk SD cards that work fine on the Pis don't work fine on the adapter.
Yeah. And yeah, you are in a nice position that you can reflash the SD card for the target system, and the image is not that big. With laptops, it's not really that simple because the disk is several gigabytes, like 128 usually, sometimes bigger. And I don't see copying that much data back and forth.
Yeah,
yes,
there it doesn't make sense. There it might makes more sense. I think you're emulating some device
Yes.
then. Yeah.
Yeah. So what I do is to install the system, and in those scripts that are supposed to copy the data, I create LVN snapshot and just copy snapshot name. And for the next test, I simply get the snapshot name and restore to that snapshot.
Okay.
It, yeah,
Well, no special hardware.
that needs some specific test ordering because if I do the installation test, it wipes the whole disk, so all snapshots are gone. So that was why I was asking about these dependencies recently.
yeah, the fact that saving an HDD or snapshots is problematic with the general hardware backend is also a reason why we usually say if you don't have to test on bare metal hardware, you better don't and use QEMU because of course QEMU handles that part much more easily. So
Yes.
That's also why we usually use it. And of course, if you really want to test on real hardware, then you have of course no better option. For this case, we had these directly chained dependencies. I'm sure you already know them, but I'm just mentioning it for the whole audience. So we have a dependency type in OpenQA which allows you to run tests more or less directly after another with no other jobs being scheduled in the middle on that host. So you can at least rely on the fact that the system is in a state of the last test in that dependency sequence. So you don't have to have a QCow image or something from the QEMU world that you can easily restore.
Yeah. For QEMU, it's I also agree. If you can use QEMU, just use QEMU. We use most of the tests on QEMU, and that's fine. But also we have some tests for hardware compatibility, so this needs to be done on specific hardware. And also on cubes, we use virtualization a lot, and nested virtualization in QEMU mostly works, but there are some corner cases that simply break. It's with Q
Yep,
and no
I
C.
guess I've found it nevertheless.
Yeah.
Yeah, just because you talked about it, I think, well, it's maybe worth mentioning, at least showing your start page. I also.
With the QEMU thing, I might mention one thing. At least for Raspberry Pi tests, they run better on real hardware. So they run in QEMU, and we do some tests, but the real hardware tests actually are more stable, than the other ones. Which is, I think, not only related to typing issues, but also because that the environment that QEMU emulates is still a bit different than what the real hardware then is, which is why I'm testing on real hardware, seeing that Wi-Fi and Bluetooth and all the other I/O crap works, and
Yeah, that's true. But also I need to test features like system suspend, which is very much hardware dependent. So
yeah, I guess systems suspend in QEMU would be funny.
yeah, it works. But if it works in QEMU, it doesn't mean it will work on the real hardware.
Yes.
So this is actually something that is the most common hardware compatibility issue for us. On one laptop it works, on another it doesn't. There are different devices, different Wi-Fi cards, different video cards, etc.
Okay. So now it was almost an hour. I guess I would officially end this call and also stop the recording. So I guess it was a nice workshop. I found it very interesting also to see a bit more what you're doing as basically outside contributor. I hope everybody else found it also interesting. So see you on the next workshop. I think the topic about that is also already settled. It's the usual roadmap talk. So see you until the next time. And of course, who likes to stay in the chat to have, I don't know, a little bit more talk about that, feel free to stay.